Okay, Pre-Algebra, welcome to 1.4 Exponents. We're going to be working practice on page 1, or section 1.4, page 16. This is exponents. I can't stress enough how important it is to really thoroughly understand what exponents are. Exponents tell us how many times to multiply the base by itself. So we're going to say, let's just say 2, that was a horrible looking 2, to the third. This is your exponent. 2 is your base, and 3 is your exponent. So this is equal to 2 times itself 3 times, which equals 8. That is super important to know what the exponent is and what the base is. If you hear me refer to a base of something, you need to know what I'm referring to. That's going to be around for quite some time. Okay, so number 1 wants us, let's see, 1 through 8 wants us to, we're only doing the first 3 examples, wants us to write the prime factors in exponential form. So it's just a faster way to write it. Instead of having to write 2 times 2 times 3 times 3, we can write that as 2, and there's 2 of them. So it's to the second power times 3, also to the second power because there's 2 of them. So that's all there is to converting these over to exponential notation. We have 2 to the first power. I don't know why this thing's not writing. Okay, so we're going to have 2 to the first power times 5, and there's 3 of them, to the third. Here we're going to have 3 times 7, and there's 2 of them, times 11, and there's 2 of them. Pretty straightforward. So number 9 through 12 wants us to expand and multiply. So we know that this becomes, kind of doing the opposite of what we just did. 3, goodness. 3 times 3 times 7. So 3 times 3 is 9. 9 times 7, 63. This becomes 2 times 2 times 7 times 7. So 7 times 7 is 49, times 2 is 98, times 2 is 190, let's see, 196. Okay, so number 13 wants us to write the prime factorization of each number in exponential form. So the prime factorization of 45 would have been, we'll just do it over here so that you can see, we just did this lesson. But let's go ahead and, so it's 9 times 5. So that would have been 3 times 5, which is how we wrote it last time. But what we're looking for is 3 squared times 5. So on 60, it would have been 2, oh good grief, 2 times 2 times 3 times 5, which is equal to 2 squared times 3 times 5. Okay, so number 16 through 23, we'll only do some of those examples, but they want us to express these using positive exponents. One thing you'll notice right off the bat that looks different about these is they have, well, the pen has disappeared here. Let me see if I can get that to work real quick. Okay, so they have the exponents, you'll notice, are negative. So on number 16, notice the negative right there. I'm not sure how familiar you are with those, that if you've come across those before or not. But the term that I'm going to use is drop it like it's hot. So we can think of 2 to the negative 8. 2 is a rational number. In other words, it can be expressed as a fraction. It's the same thing as 2 to the negative 8 over 1. The way we change these negative exponents to positive is we drop it. That's the same thing as, I'm going to put the 2 to the 8 in bottom. When it goes across that fraction bar, the sign in front of it changes. Sometimes we make it positive, and sometimes it's beneficial to make it negative. Maybe we take a 2 to the positive 8 from the denominator up to the top as a 2 to the negative 8. Now we have a 1 placeholder up here. So those things are exactly the same. So that's what we do there. 5 to the negative 7th is equal to 5 to the negative 7 over 1. I'm going to drop it like it's hot. 1 over 5 to the 7th. Here's an example where we're going to go the other way. So it's in the denominator as a negative exponent. I'm going to take it to the top. And there's only a 1 out there, so it just becomes 7 to the positive 3 over 1, which is just 7 to the 3rd. Same thing here. I'm going to skip that middle step here. When I see that it's a 1 in the numerator, and I've got a negative exponent on the bottom, I'm just taking it to the top. And because it's over 1, that's understood. I don't need to write it. Now 24, this one wants us to write them using negative exponents. So that's what I was saying a minute ago. Sometimes it's beneficial for us to have a negative exponent to get rid of a fraction. So that's the same thing as if I take that to the top, when it crosses that fraction bar, it becomes the opposite sign. So it was positive over here, but when I took it to the top, it became negative. Again, I don't need to show that 1 on bottom, so it's just 2 to the negative 3. I can immediately recognize I want it to be no fraction, so I'm going to change the sign of the exponent. That's 7 to the negative 5th. I would say probably practice showing it as a fraction like we did on number 24 a few times until you get the hang of it. And then I don't mind if you just skip straight to that answer. That shows that you thoroughly understand what you're doing. Let's see, number 28 through 31 wants us to express using positive exponents. Then we're going to expand it and multiply it. So we want to solve this. So I'm going to make the exponent positive first, drop it like it's hot. That is 1 over 8, because 2 to the 3rd power is 8. 2 times 2 is 4, times 2 is 8. Here we got, I'm just going to take it up to the top. 5 squared equals 25. 1 over 11 squared equals 1 over 121. This is 1 over 5 squared, which equals 1 over 25. All right, so we kind of went both ways. We usually will make the exponent positive by taking it up or down in the fraction, but sometimes it's beneficial for us to go negative, so we need to be familiar how to do that. And I cannot stress enough, you have to really understand what the base is and what the exponent is. The exponent tells you how many times to multiply the base by itself. Example, we'll go 2 to the 5th this time equals 2 times 2 times 2 times 2 times 2. Alright, so obviously it's a whole lot shorter to write 2 to the 5th than it is 2 times 2 times 2 times 2, especially if you get into high ones like 2 to the 50th. Alright, let's move on to 1.5.